everyone. Today I explain you about atomic number and atomic mass number. We represent atomic number by Z. By which? Z. Atomic number is equivalent to number of protons or number of electron. Okay, and what is atomic mass? Atomic mass is represented by letter A, and it is equivalent to the sum of number of proton plus number of neutron in the nucleus. Okay. Now let's take one example. Here I have taken one atom in which in the nucleus 6 protons and 6 neutrons are lie, and in its orbit 6 electrons are revolving around the nucleus. Now here we find the atomic number and atomic mass. So atomic number is equivalent to, as I told you, atomic number is equivalent to number of proton or the number of electron. So the number of proton is equivalent to 6. So the atomic number that is equivalent, that we denoted by Z, is equivalent to 6. So we can say atomic number Z is equivalent to 6. Atomic mass is equivalent to the number of proton plus number of neutron. So here we have 6 proton and 6 neutrons, so we write down 6 plus 6 is equal to 12. So the atomic mass is equivalent to 12 and atomic number is equivalent to 6. So in this way we can calculate atomic number and atomic mass of a atom. Let's take one example. Here we have, this is given to us. From here we have to find the number of electrons, number of protons, Z, A, and number of neutrons also. Z is atomic number, A is atomic mass. From here, just see this one. If this one is, we represent it like this. Atomic numbers are located here and atomic mass we represent it here. So it means Z is equivalent to 6 and atomic mass is equivalent to 12. From here we can find. Now just have a look here. Number of electron is equivalent to number of electron is equivalent to atomic number. And atomic number is equivalent to 6. So the number of electron is equivalent to 6. And number of electron and proton both are same in an atom. So we can say number of proton is also equivalent to 6. Now number of neutron is the number of neutron. How do we calculate number of neutron? So N is equal to A minus Z, or we can say N is equal to A minus number of proton. N is equal to A minus number of protons. Because Z is atomic mass and that is equivalent to number of proton or neutron. So from here A is equivalent to 12, it is given to us. So you subtract number of proton, that is 6. So you will get number of neutron. Number of neutron is equivalent to again 6. So N is equivalent to 6. Let's take one more example. Here we have 39 K 19. This one is given to us. From here we find number of proton first. P is equivalent to, now just see this one, K is equal to ZA. So atomic number that we represented by Z. So number of proton is equivalent to Z. This is equivalent to 19. And electrons are also equivalent to proton, that is equivalent to number of atomic number. So it is also equivalent to 19. Number of neutron, then how do we calculate number of neutron? Number of neutron is equivalent to atomic mass minus atomic mass minus atomic number. Atomic mass minus atomic number. So A minus Z. So A is equivalent to 39 and Z is equivalent to 19. So from here we can calculate that is equivalent to 20. So number of neutron in the nucleus is 20. Okay. Now here the question is, if an atom X contains 19 proton, find the number of electron and atomic number. Then how do we calculate this one? Number of in an atom, number of electron and proton both are equivalent to each other. So we can say number of electron is equivalent to number of proton, that is equivalent to 19. And the same way atomic number is equal to number of electron and number of proton, and both are equivalent to 19, so we can say atomic number is also equivalent to 19. Okay. Suppose in this question we have the value of neutron is equal to 20. Then how do we calculate number of atomic mass? Then how do we calculate atomic mass? Let's see how do we calculate atomic mass. Atomic mass is equivalent to neutron plus proton. Number of neutron plus number of proton. Number of neutron it is given to us 20 and it is number of proton is equivalent to 19. So that is equivalent to 39. So in this way we can calculate atomic mass, atomic number and number of electron. Okay. Now what is the electronic configuration? According to this configuration, all the proton and neutrons are lie in its nucleus. So whole positive charge lies in its nucleus and all the electrons revolves around the nucleus. But the question arises in my mind that the whole of the positive charge lies inside the nucleus and all the negative charge revolves around the nucleus. But what is the reason behind it that they are not falling on the nucleus? Anyone can guess? Yes, because the centrifugal force prevents them falling into the nucleus, because it provides some centrifugal force. So because of this force they are not falling on the nucleus. In this configuration, all these are called energy level. These are called energy level. These are called energy level, and these are having certain energy. These all shells have certain energy. So we can represent it by K, L, M, N and so on. In this way, K, L, M, N and so on. These all orbits have certain specific energy. Shell closest to the nucleus is called K shell and the next shell is called L and then so on. The maximum number of electron which can be present in any of the shell of the atom is represented by the formula that is called 2n square. That is called 2n square. Suppose I am talking about the K shell. So it's a first shell. So we can, if we find the value of number of electron in it, then how do we calculate? 2 multiply n means number of shell. So this one is called 1 and this is equivalent to 2. So maximum 2 electron can stay in the first energy level, KL. Now L is a second shell, so we can write 2 multiply 2 square. That is 2 2s are 4 into 8. So maximum 8 electron can consist in the second shell, KL M. M means third shell. So it is 2 multiply 3 square. And it is 3 3s are 9, 9 2s are 18. So maximum 18 electron can stay in the third shell, that is M shell. M, N, and the same way we can find from here also. It is a fourth shell, so we write down 4 square. 4 4s are 16, 16 2s are 32. So maximum 32 electron can stay in the fourth energy level. Okay, but the outermost shell cannot have more than 8 electrons. Outermost shell cannot consist more than not more than 8 electrons. Not more than 8 electrons. Cannot consist not more than 8 electrons. A new shell is formed as soon as the outermost shell attains 8 electrons. Okay. Now, suppose I am taking one example, that is calcium of Ca 20 and 40. I am taking this example. Here atomic number is 20. It means number of electrons are equivalent. Number of electrons is equivalent to 20. It means first shell, it contains K. K means 2. As we found, K is equal to 2. KL, L is equal to 8, M is equal to 18, N is equal to 32. Okay, but the outermost shell consists 8 electrons. KL, L is equal to how many are remaining? The C, 20 minus 2, that is 18 are remaining. But in the second shell only 8 electron can fill up. We can fill up. So here we write down 8 more electrons. The 2 plus 8 is equal to 10. So if we subtract 10, then 10 more electrons are left. But as I told you, in the last orbit, in the outermost orbit, maximum 8 or 2 electron can stay. So what we write down, KL, M is equal to, again we write down 8, and then N is equal to, it is 2. Here it is 2. We can fill up in the outermost orbit, we can fill 8 or 2 electron, maximum 8 or 2 electron. Okay class, and this one is called octet rule. Atom of various elements enter into chemical combinations so as to attain the configuration of 8 electrons in their outermost shell or 2 electron if there is only one shell. Is it okay? So the configuration of calcium is 2, 8, 8, 2. Yes, I am giving you one more example. Example of chlorine, that is 17. So the number of electrons are equivalent to 17. So here we write down, so K shell consists of 2 electrons, KL shell consists of 8 electrons, so 2 plus 8, 10. So if we already filled up 17 minus 10 is equal to 7. So we all how many are left? So only 7 are left. So in M shell we can fill only 7 electrons. So this is the configuration of chlorine, that is called 2, 8, 7. I am giving you one more example. Numbers are equivalent to 19. Atomic number is equivalent to 19. It means number of electrons that we can fill in its orbit, that is equivalent to 19. So first we write down for K. K is equal to, first we can fill only 2 electrons. So we write down K is equal to 2. If we subtract 19 minus 2, how many are left? Now 17 are left. So KL, how many can fill? Only 8 we can fill. 8 we subtracted, how many are left? 17 minus 2 is 17 minus 8 is equal to 9 are left. In the last orbit, how many we fill? As I told you, in its last orbit, we can fill up only how many? 2 or 8 electrons. Just before the outer orbit, we fill up it completely. So KL M is also equivalent to 8. KLM N is equal to how many are left? 1 is left. The question is, give the diagrammatic representation of atomic structure of the element given above. Here we have to give the diagrammatic representation. First we calculate how many electron we fill up in its orbit. Just see, 7 is given to us. 7 means in first orbit we fill up only 2 electrons. In the next orbit, how many are left? Only 5 are left. 2 plus 5, 7. So how do we write this one? First we make nucleus. In the nucleus, how many are number of protons are equivalent to 7. So number of neutron is equivalent to 14 minus 7. 14 minus 7, that is again 7. So it means proton is equal to 7 and neutron is also equivalent to 7. In its first orbit, how many? 2. So here we write down. Here we fill 2 electron. In the next one, 5. So how many? How do we fill? 1, 2, 3, 4, and here I am filling 5. Okay. So in this way you can fill.